Up next on Eco Company.
Say goodbye to buildings that are bad for the planet.
This is just like the Jetsons.
We tour a building that is setting the standard for building it green.
Plus, you've all seen solar panels, but how about one of these? A balloon that captures the power of the sun.
And it's changing the face of solar.
Then we visit one of the few biofuel labs in the world.
This lab is really working on the feedstocks, which is the origin of all biofuels.
We'll find out how these plants can produce a cleaner fuel of the future.
And we're heading into the kitchen, but this isn't your normal kitchen.
So a more efficient stove is one that, given the same cooking task, will be able to do it with less fuel.
They're researching energy efficiency. Gloves required. All that and more
On Eco Company,
starting right now.
Hey guys, thanks for tuning into Eco Company. I'm Jordan.
And I'm Jelena. When you think about the environment, you probably think of oceans, forests, open spaces, and fresh air.
But the fact of the matter is, the majority of us live in urban areas where there are a lot of people, a lot of cars, and a lot of buildings.
And the biggest challenges in reducing carbon emissions and finding alternative energy sources.
That's right. Buildings present one of the biggest challenges. They use up a lot of resources and energy.
But they don't have to. It's all about building it green.
Buildings, big and small, short and tall. They take up a lot of space on our planet. Did you know they're a bigger source of greenhouse gas emissions than cars? The U.S. Energy Department says they account for nearly 50% of our energy consumption and CO2 emissions. Globally, that number jumps to nearly 80%. Conventional cement alone is estimated to emit more CO2 into the atmosphere than the entire global airline industry. So what can we do to make buildings more eco-friendly, save energy and resources? Learn how to green them up fast. That brings us here, to the David Brower Center in Berkeley, California, named after the environmental pioneer and former executive director of the Sierra Club. Wall to wall, ceiling to ceiling, this place is packed with ways to build it green. Executive Director Amy Tobin is giving us a tour.
So what are some of the key features that make this place green?
There are so many. The first is that it has a narrow floor plate. So the building itself is very narrow to maximize daylighting deep into the offices. So when you think about an office building, usually you don't think about fresh air and natural light. And this building is really focused on that. The entire design was oriented around maximizing light into the offices.
More natural light means less of these, a big energy savings. A greener concrete cuts the carbon footprint too.
So this is made of concrete and a little something else.
That's right. So we have a very high percentage of slag in our concrete. And slag is a byproduct of steel manufacturing. It's usually a waste product. So by using slag mixed with cement, we use less cement, and therefore there's less CO2 production.
It also uses a bit less water than used to make conventional cement, which brings us to something rather unique in the bathroom.
So yeah, I understand that restrooms are a place where a lot of water is used, a lot of energy. So what are you doing to conserve that?
There's a lot going on in here. So as you look into this stall,
Maybe we should flush that first.
that's rainwater.
Oh,
So that's
really?
actually been flushed. We're collecting rainwater in a cistern in our basement and using it in the toilet. And we have filters, but it still comes up that color. So we realized we had to put a sign up because people were coming in and flushing the toilet. In the men's room, we have the first waterless urinals in Berkeley.
Water-saving fixtures dot the sinks, surrounded by recycled glass countertop. But one thing you won't find is paper towels.
This is just like the Jetsons.
Instead, energy-efficient dryers do the job. Now that my hands are clean,
Wow.
time to move on.
You have your own theater.
That we do.
This place is also full of bamboo, a green choice because it grows so quickly. The seats are special too.
Pretty comfortable, right?
Very.
Oh, I'm putting my feet up on the seats. I'm not supposed to do that. There's recycled content in the fabric. It's non-toxic. It's recyclable. And then the carpet in this room is entirely made of recycled carpet.
That's inside. What about the exterior?
Something tells me that this office building wall is not your typical office building wall.
You're right. This is zinc siding instead of aluminum. And zinc takes less energy to extract from the earth. It lasts for longer. And then see these white shelves here?
Okay.
Those are sun shading devices that help control the heat gain into the offices. And they also reflect light into the offices.
And on the roof,
Wow, so these are the solar panels you're talking about. How big is the system you're using?
58 kilowatts.
Wow.
It's providing about 40% of the building's energy.
So is there a way to figure out how much energy we're using right now?
Yeah. We're monitoring all of the building systems, and anyone, anywhere can go online to our website and see exactly how much energy we're using at any given time, how much water we're using, how much solar energy we're using.
so from its energy-saving design to its eco-friendly building materials and water-saving measures, the David Brower Center is doing its part to cut its carbon footprint. It's all part of an effort to create greener skylines everywhere, one building at a time.
Solar panels are a great idea and definitely a growing source of renewable energy.
But here's another one for you, solar balloons.
That sounds like it could be pretty cool.
It's a cutting-edge new technology we had to see to believe.
It's reflecting the power of the sun to create energy here on Earth. Sure, we've heard of solar power before, but we've never seen it quite like this.
This is our inflated solar concentrator. It's made of thin film plastic, and we use it to concentrate the light and produce electricity.
Rob Lampkin is the CEO of Cool Earth Solar, a company that's designing and building new solar balloons to power the planet.
We're not doing it with just flat panels. We're using these balloons to concentrate the light and harness much more of the sun's energy that we get.
Inside, the sun's rays are concentrated on a solar photovoltaic cell in the middle. That cell then converts the sunlight into electricity.
We use two-axis tracking so that we can continually keep these concentrators pointed right at the sun so that we can focus the light and make the electricity. You can see what the focal point is now on the front surface of the film. Its front surface is just clear, thin film plastic, and the back surface started out as plastic, clear, like this, and then a very thin layer of aluminum is vacuum deposited on the film, just a few microns thick, and that creates a nice mirrored surface so that when we inflate it, we get a very nice solar concentrator that's very cheap, very lightweight, and quick to deploy.
So how much do these weigh? I mean, it's a balloon.
It's a balloon and it's a solar concentrator. The amount of plastic in this 8-foot inflated solar concentrator is between 1.5 pounds and 2 pounds of plastic. It will hold about 10 pounds of air.
And it doesn't cost a lot to get 1.5 pounds of plastic, does it?
Just a couple bucks. And so this is really the magic of the Cool Earth technology and why we're able to produce solar energy so much cheaper than the other technologies that are out there today.
Donna is a student from MIT. She's an intern here and helping them test the plastic.
This is the reflective film that goes on the back, and on the front we put this clear film.
And this is to protect the reflective film, I guess?
This filters out some of the UV from the sun so it doesn't damage the solar cell as much. And then the sunlight comes through here, and then it also protects the solar cell on the inside.
So what are you testing the plastics for?
We're testing them to see how long we can get them to last in environmental conditions, because these things are going to be outside for a whole year. So they're going to be rained on, it's going to be hot, it's going to be humid, and so we have to make sure that these can hold up to whatever happens outside. Yeah, that they're durable.
This is all recyclable, so we can take a balloon, recycle the plastic, and make another solar balloon.
Each one of these 8-foot concentrators can produce about 1 kilowatt during peak hours. A home uses about 2 to 3 kilowatts, but Lampkin says their plans are much more global.
We need to be covering thousands and thousands of acres. And so that's how we see these concentrators deployed. Hundreds and thousands of acres at a time across the world, each generating a kilowatt. You add it all up and eventually you start producing gigawatts and terawatts worth of energy, which is what we need to address our growing and very large energy problem that we have.
With the global demand for energy expected to grow nearly 50% by 2030, their goal is to make solar cheaper and reduce our dependence on fossil fuels.
We have to drive the cost of solar lower. It's not a technology problem at this point. It is hard engineering work, driving the cost down so that nobody will want to build a coal plant in the future because this will be available and it will be cheaper.
It's a problem Donna plans to continue to work on herself.
It just seems to me that this is a really big global problem, and it's probably the best place that I can devote my effort to make a difference in the world.
Improving the way buildings are built and using renewable energy, it's a great way to start.
But there's still a problem with cars and greenhouse gases.
Up next, we found one group of scientists with a new idea.
More Eco Company is coming up. Okay, so now it's time to tackle the challenge of renewable fuels for our cars.
Could nature have a few tricks up its sleeve?
Indeed it could. What if plants and grasses could be used for biofuels?
We're tracking down the scientists, hoping to make it happen.
It's high-tech science that could change the future of fuel. This is JBay, otherwise known as the Joint Bioenergy Institute. It's a place working to unlock some of nature's secrets, to create plant-based biofuels to replace fossil fuels.
Researchers here at JBay are really looking at trying to create gasoline and diesel using fermentation that could be a direct drop-in replacement for gasoline and diesel that you use today, and also the aviation fuel that we use to fly around it.
Blake Simmons is a top chemical engineer working to develop this next generation of biofuels. Liquid fuels derived from solar energy stored in plant biomass.
Biomass is defined as anything that's photosynthetic, that utilizes sunlight and CO2 to grow, and basically produces polysaccharides into the plant cell wall. And so when you're talking biomass, it can be trees, it can be grasses, it can be mold, it can be moss. It can actually be a variety of different formats.
They're experimenting with inedible plants, grasses, and even trees. Sugar polymers inside their cell walls store the sun's energy. But unlike starches like corn used for ethanol, these sugars can be hard to get. This is the first step of the process, so what's happening in here?
So this lab is really working on the feedstocks, which is the origin of all biofuels. What they're trying to do is understand what are inside the plants that make them harder to process, and then come up with engineering methods to break them down easier and produce sugar very effectively. What they're doing is growing plants. We have a variety in here, as you can see, that we're growing. It's under very carefully controlled environmental conditions, so we can, really try and understand the science about what's going on as these plants grow.
They're looking for high-density plants that grow fast, so they can provide a rapidly renewable source, and a lot of it.
This is tobacco. This is only for studying, not for smoking or chewing, so it's very important to note. And the reason why we use tobacco plants is that it's much like the Arabidopsis. It grows very fast, we understand it very well, and we can determine the impact of these genetic knockouts and genetic engineering on the plant system itself.
Once they've isolated some possible contenders, Simmons gets to work.
This is where the next part of the process from biomass to biofuel occurs.
This is step 2.
This is step 2, exactly right. This is where we take the pretty plants and we break them down into sugar.
So what is all of this right here?
So this is what we need to start with when we get to step 2 of the process, right? So I showed you the feedstocks when they're growing. This is after they're harvested and dried. So this, for instance, is switchgrass that's been milled up and ground up, and that is one of the starting materials that we use.
This step is called deconstructing. They take the dried material and put it through several process steps where it ends up in a liquid state to be analyzed.
We solubilize it and it comes out looking like that. And then when you dry it and recover it, then you get that fine powdery material out. And then you add the enzymes and then you've got sugar.
That's where this special robot comes in. It's designed to help test and develop better enzymes that are critical to the process.
What this does is it basically saves a lot of time, makes the system more efficient, and we can screen thousands of different potential enzymes per day.
But we're not there yet. Once you get the sugars, they're fed to bacteria to produce the fuel. This machine is picking out colonies of bacteria to use. Once the bacteria and sugars are combined, they go into here.
These microbes are actually being grown for the fuel synthesis team. And so they're actually producing the little molecules of fuel from the sugar that we feed them. And then we let them grow for a certain period of time, we bring them out, we harvest them, and then we analyze what they're doing.
J-Bay hopes to achieve significant progress within the next 5 years.
There is no bigger problem than global warming that we can work on as a scientific community today that will have a significant and long-term impact.
And Simmons says they're going to use some help.
The United States really needs a next generation of top-tier scientists in mathematics, and I really encourage everybody who's watching this to really think about going into science and engineering as a career. I think it's extremely rewarding, and I hope to see some new fresh faces that can help us out with this effort.
It's an effort that will have a big impact on the planet and on us all. Up next, we head into the kitchen.
Well, it's really a lab.
But here they're testing cook stoves, which are used by about half of the world's population. More Eco Company is coming up.
Have you ever thought about all the energy we use at home?
Especially in the kitchen. You may have a gas or electric stove.
But imagine if everyone had to use wood or charcoal instead.
That would be really bad for the environment.
And in most parts of the world, there aren't any other options.
But that's where some Berkeley researchers come into play.
These are test chambers at the U.S. Department of Energy Lawrence Berkeley National Laboratory, a place where researchers like intern and high school chemistry teacher Alan Boltz are heating things up. Cook stoves like these are used by people across the globe.
Between 2.5 and 3 billion people, so about half the world's population cook on open flame every day for their food.
The problem is that a lot of these use charcoal for fuel, and not very efficiently. And since charcoal is a fossil fuel, that means it's giving off CO2.
The amount of, particulates, like if you've ever been around a campfire and you get that soot on you, it's like all that soot goes up into the atmosphere. Now multiply what you just did once by 3 billion 3 times a day. So the numbers, when we look at it that way in terms of that exponential impact, then it really began to make sense in my mind, the need for more fuel-efficient stoves.
There's another big problem too. Charcoal takes a lot of wood to make, and in countries that rely on it, like Haiti, forests are almost gone. This NASA image tells the story. The green on the right is the Dominican Republic, the brown, that's Haiti.
In Haiti, about 98% of the country has lost its forest due to the production of charcoal. So they're kind of working at an environmental deficit right now.
That's where this lab comes in.
And the Berkeley lab was basically asked to test all the stoves to look at efficiency. That way, as the NGOs or non-governmental organizations in Haiti are distributing the stoves, they'll have an idea of what's the most efficient versus the cost and ease of use and all those other variables. It's definitely climbing.
Here they're using a 3-phase international standard water boiling test to see which ones do the job.
At this elevation, the boiling point here is actually 99.9. We just had to transition, take all of our measurements, how much charcoal was still in there burning, how much water we had lost due to evaporation and boiling. And now we want to get it at a simmer point and keep it there for 45 minutes. And that simulates basically cooking rice or beans.
They already know traditional stoves aren't good options, though they're popular because they're easy to make.
One of the downsides of it is they're pretty inefficient. Because of the large fuel size, you could really stuff them full of charcoal, which a lot of that is then going to go to waste as heat that's escaping out the sides.
This one's not much of an improvement. To get that, you need 2 things. A smaller area to put fuel.
You see efficiency go up just because people can't overfeed it.
And insulation.
Based off of the physics and the mechanics behind heating, we are going to see an increase in efficiency with insulated stoves, just like you would at your house.
This one's a modified version made in Haiti.
The clay itself will hold a lot of heat and be able to give that heat back during longer cook cycles.
As for the one over the coals right now, it uses fiberglass instead of clay, which works too. At the end of the day, Bolt says it's about finding a solution now.
With this information, as soon as we get the analysis and the efficiency, it'll be used immediately in Haiti to help the people there now.
It's helped not only in terms of energy efficiency and cleaner air, but also for saving what's left of Haiti's forests too.
That wraps things up this week on Eco Company. Thanks for tuning in.
For more information on the stories in the show, or to give us your feedback, visit our website at eco-company.tv.
And remember, you too can be a part of the solution.
We'll see you back here next time
on Eco Company.